You'll notice that underneath this blue sphere, the shadows are bluish, and even the surrounding white ground is kind of bluish because it's reflecting off of this ball, and the ball is also reflecting the white of the plane that it's on. Same thing here. Look, this is redder here, and they're reflecting each other. See? Look. They're meant to be. Okay. It's reflecting the light source, and it's a good looking render. Thing is, this is a crappy render. Okay? So look, the render gets better and better by adding more stuff to it. Okay, so let's start off with the basics. So let's make a simple ground plane. Alright, simple ground plane. In this ground plane, I'm going to right mouse click and assign my favorite material, which is a blend material, and give it the color of white. Okay, and then I will remove reflectivity from it, because by default, with a blend material, it gives it 50% reflectivity. So I'm going to change the 10 to 0. Okay. I'm going to, I'm going to go to the render options here, and by default Maya software is enabled. I'm going to change the production quality, the anti-aliasing to production quality. Okay, let's add an object to it, the same, let's use a cylinder this time, just to be different from the first demonstration, just for the heck of it, right? Okay. Excuse me. In this cylinder, I'm going to assign a material to it, blend, and then I'm going to color this thing red. Right. Okay. So right now this is set to Maya software, and Maya software is adequate, but it's kind of ugly. So a renderer translates a 3D scene into a 2D image. So the basic for this is Maya software. So if you actually do a render, you get this. Alright, let's do the standard. What the heck is wrong with this thing? No shadow? 2. It is flat? Yeah. This is supposed to be reflective, by the way. So it's not reflective at all. What else?
No light.
There's a fly.
There's a fly.
Why is there a fly? I've never seen a fly in a lab here. Okay. This monitor is sweet. Okay. Alright, we'll get to the other things, but there's a lot of things missing here. Okay. So the first thing is there are no shadows. By default, when you render something, Maya uses default lighting, which means there's a light attached, an imaginary light attached to the camera. So if you do a render, the light shines directly onto the object. 1. Okay, we don't like that. We're going to make our own light. So create lights, and there's a bunch of lights here. Now, I'm going to just talk about one light because lighting is a separate topic in itself. This is just rendering materials. And we're not even going to cover this in depth just yet. There's 3 more meetings for that. So, I'm going to create an area light. So what an area light is, well, it's an area of light. Very simple, alright? And this area of light is square. So I'm going to just position it like this and kind of move it up. So the area of the light is important. The more area there is, like the bigger the square, the more light it actually emits. Okay, second thing, I'm going to lock the camera down. So view, select camera, and then I'm going to set a keyframe to it so I can move this thing around and it always locks into the same view. Okay, and let's do a quick render. Okay, so thing is, still no shadows. Alright, let's enable the shadows, and then you can do that by going to the attributes of the light. So I'm going to select this light, press Control A, the attributes will pop out. Maya has two types of shadows. The first is called a depth map shadow. So depth map shadow uses a fast way to calculate a shadow, but is less physically accurate. This means that if there was transparency in an object, the light won't shine through it. Okay? Plus, it's physically inaccurate in more ways than one, but I won't go into detail. I will say, though, that it renders faster, but consumes more RAM. Let's add that shadow. So use depth map shadows, and I'm going to click render. Alright, so now we have a shadow. And I'm going to save that shadow for demonstration later. What's wrong with this shadow? It's too solid, it's too black, because shadows in real life, like the shadow on this mouse or on my hand, for example, there, the shadows are darker the closer it is to the object that casts the shadow. The further away the shadow is, the lighter it actually gets. So this doesn't work at all, because depth map shadows are always flat black. I mean, we can change the shadow color. For example, I can make this gray, like this, and if we do a render, it'll be gray. But this doesn't really solve the problem. It's just one color, right? And you can see it from here when I made it gray and rendered it, that it's actually lighter the closer it is to an object, which sucks. Real shadows don't work like that. So, why use it? Because it's fast. It's fast. Okay, so it is fast. Sometimes, like everything in life, scheduling is everything. You need this done. But if you use the other option, it'll render slower. So you do it this way. The second option are called ray trace shadows. It uses more CPU, slower, but more accurate. The thing is, if I turn that on right now, so I'm going to turn depth map shadows off, and I'm going to turn on ray trace shadows on, and do a render, nothing will happen. Okay, because you have to tick off an option inside of the render options. So let's go to render options, and the option that you want ticked or checked is ray tracing quality. Right now there's no ray tracing at all, which explains why this thing isn't reflecting anything, because reflectivity is controlled by ray tracing. So we're going to turn ray tracing on. I'm just going to leave it at the default, and let's do a render. Okay, so it's better. It's actually reflecting the ground, right? However, you can see that the shadows are kind of, it's darker here and lighter here, but it looks like it's roughly penciled in. The noise is unacceptable, unless of course you're going for that look. Okay, let's save that. In order for this to look better, we need to up the amount of shadow rays that's being cast from the object. So right now the shadow rays are set to 1. So I can set this to 10. If I do a render, the shadows look better. Alright, see, looks better. I can continue upping this to make it look better and better until it reaches the point where upping it will just make the render longer. At this point, the render is 9 seconds. Okay, so earlier the render was about, 3 seconds, 9 seconds. So it's actually 3 times more, 300% longer. Also, the light is kind of inaccurate because the light is casting infinitely at a set rate, which is unrealistic because light actually starts to get weaker the further away it is from the source. So we need to change that as well. So right now, the light isn't decaying or getting weaker the further it is from the source. So let's change the decay rate from no decay to cubic. If I change this to cubic, this means that there are 3 different types of decay, and cubic just cubes the amount of decay for every set distance. Linear, quadratic, it's just mathematical. You can look it up. So I like cubic. But if I use just cubic, what will happen is everything's going to be black because the light can't reach our cylinder or even the ground, right? Right. So let's change that. Let's change this to about 100. And let's do a quick render again. Alright, so it's getting better. Yeah, it's getting better. But it's still a little bit too dark for me, so maybe 200 will do. And you can see that this is better because look, the light here is brighter, but the light here is steadily tapering off, right? Looks better. Okay, and this cylinder is, well, looks better. Alright, so now we have the light how we want it to be. So if we compare it with the quality of the ones before, see? Here to here to here to here to here, looks better. But this is still not a good render. Now, superficially, hey, this looks awesome, but it ain't. And the reason for this is a phenomenon called global illumination. So what global illumination does is that it takes into account everything that's in the scene, and then it reflects every light ray on top of every other object and mixes them together. So essentially, what this means is the colors should bleed from one object to the next to everything around it. So this happens in real life. If I put a red ball here, there's going to be, this area is going to be reddish on the table because it's reflecting the red ball. Alright? This is not happening because Maya software doesn't have that capability. So we have to use a more advanced renderer. So Maya ships with about 4 different types of renderers. And the more advanced renderer is called Mental Ray. So I'm going to use Mental Ray, and I'm going to do a few options to it. First, let's change the quality. And let's change this to production quality. Alright? Second thing is, I need to turn on global illumination so that light rays will bounce all over the place like it does in real life. So I'm going to click global illumination. And finally, in features, I'm going to turn on an option called ambient occlusion. So what ambient occlusion does is it allows light to be sucked in if more than one object is close to each other. So for example, the corners of the wall right there, it's darker there. Why? Because they're close to each other. It's a physical phenomenon. So ambient occlusion simulates that physical phenomenon. Doing all that doesn't do anything yet. You first have to make sure that the light source is compatible with global illumination. How do you do it? You must make it fire off physically correct light rays. And in Mental Ray, those are called photons. So select your light, scroll downwards to the Mental Ray area. Okay, keep scrolling downwards to global illumination, acoustic and global illumination, and then click on emit photons. Okay, you're good. So now if you click on render, let's wait for it. Oh yeah, every option that you turn on makes the render longer. Joy. Okay, can you see the red spreading all over? Let's save this and let's move it. Can you see it?
Yes.
Yes. Could you ever have known that before? No. Yeah, I mean if you made a study of light, right? This is the stuff that makes stuff look good. It's subtle, nobody really knows about it, but it does make it look good, and you can't explain why the hell does it look good? It's like explaining a beautiful woman. Can you explain a beautiful woman? You can't. What makes a beautiful woman? Exactly, right? There's so many variables that you can't tell what makes up a beautiful woman. It's the same thing here. The light is bleeding. The light is bouncing off. There's reflections. The shadows are blurred. The shadows are darker, closer to the source. There's just so many things to think about when you say it's a beautiful render. Now this subtlety is on the very best rendered films, like Pixar movies, like How to Train Your Dragon 2, right? Stuff like that is gorgeous. It's beautiful. But why is it beautiful? So here's a partial explanation of that. Okay. Let's add a sphere. And this sphere we shall make into a blend material. And just like with the earlier example, I'm going to change it to a different color. How about, what's a good color? Yellow?
Green.
Green?
Green.
Green. Yeah. Green is a good color. Lime green? I hate lime green. How about a warmer green?
Yes.
All right. Okay, and let's set this up here. Let's do render. So the green of the ball will bleed into everything else, right? Right. Let's wait for it. See, look, this is greenish already. You can see it, right? And you can see that the red of the cylinder is mixing with the green here. See? See that subtle change of color there?
Yes.
All right. And you can see that this is reflecting the cylinder, and the cylinder is reflecting the ball. All right. Pretty.
Pretty.
Okay, of course it is a bit lime green, which is painful to the eye. All right. And it's also reflecting the light source. Okay. This is a basic explanation of it. Any questions, people?
Sure, what if
Phone. Well, actually, the thing is, right now we're using Maya materials, but if you right mouse click it and assign a new material to it, you can actually use mental ray materials which actually have a better look to it, like built-in BSDF foam or DGS material, or you can simulate car paint just by, well, selecting car paint, right? Or you can make something even cause light to happen. Or you can simulate skin by using the skin shader. Or you can use a basic material like MIA material right here. Okay, but we'll do this in-depth discussion when we start rendering other things.
Sir, bawat attribute may different settings or same settings?
No, different settings. Okay, so there's a lot to learn and a lot to apply. Any other questions, people? Oh yeah, you might want to look at this. This rendered in 23 seconds. This rendered in 7 seconds. 23, 7. So this is 300% longer. So what if this was minutes? What if, look, this is a simple cylinder. What if you had a full scene, and a full scene rendered 5 minutes, and you added all the fancy effects in? So it's going to be 300% longer as a rough estimate. So if it took 7 minutes to render that, add in all these fancy things, then you get 23 minutes of render, right? Per frame. Which becomes painful. Okay?
Things that make you go Asian.
Yeah. So the thing is, and I noticed this with most students, organization is king or queen. So yeah, look, you don't have the fastest computer in the world. You don't have as many computers as you like, but if you schedule everything correctly, you can make it through to the finals. It's all a matter of discipline. Application. If you do not have these things, you will not pass 3D. Because you must start rendering 3 weeks before finals. If possible, you should even start rendering even before finals is in sight. Okay? Yeah. All right. you practice discipline, you apply it, you will get this thing done. Yes.
Load in new materials in Maya.
Yeah, you can download materials from elsewhere. Yeah, or you can make your own materials, which we haven't talked about just yet. We can mix and combine materials using the node editor. And, well, we haven't gone to that yet. But, yeah. See, look, this is
Using tire.
this is the hypershade, see? We can actually connect materials up. Like, for example, this blend material right here, I can actually connect it to the output of this material right here, or the incandescence of one material there, and create and mix my own material. Okay, but this is for another discussion. This is a bit more advanced. So you can actually create your own material, save it, and then reuse it elsewhere. Fun. Aside from the built-in materials.
Sir, yung type of video sa mga parang render ng walking dead, parang 2D.
Sure. I'll show you an example.
May outline na.
Yep. Let's use a sphere. Let's add a light. So, I'm teaching you people how to render photorealistically. Example, Cloudy with a Chance of Meatballs was rendered photorealistically, but its subject matter wasn't photoreal, but it still looked awesome, right? Great. So, let's add an area light here. Okay, and look. Let me just alter this ball. Vertex. Alright. Okay. Maybe let's add a dent to it here. Alright. And let's convert it. Modify. Convert polygons to subdiv surface just to smoothen it out. Okay, look. Let's add an outline to it. And let's do a quick render. Let's make this totally white. Sign. Favorite material. Let's Lambert. Let's make this white. Let's make it slightly incandescent. Right. You can even see that line right there. See? Yeah. Look. See? Outline. Let's make this production quality. And let's change this into a toon render. See? Look. You can even change the outline so that there's thickness and thinness to the outline, like this. So let's change the line width. We can make it thicker, we can make it thinner. We can add a map to the line width. Let's do line surface, for example. And let's do line end thinning. Let's do another quick render. There you go, see? We can change the parameters of the material. Like right now, it has these colors, but we can change the color of this to whatever we like. Alright, let's change the highlight and make this yellow. Alright, and let's blur them together. So let's make this smooth. Alright, and let's change this to smooth as well. Let's change this to smooth. Alright, and let's do a render. There you go, see? Yeah, you can do borderlines. And look, this is it, animated. Okay.
Kaso mas matagal na yan.
Not so much, actually. Yeah. It's just that this computer is slowing down because, you know, this effects takes a while to actually do. You can even make it stylistic.
So hindi kumbaga, nagiging 2D na siya sa 3D
Yeah, it looks it's 3D, but it looks 2D. Kind of like
paper map.
yeah. Have you ever watched? Do you know the band The Gorillaz?
Yes sir.
Have you seen their music videos?
Mm.
Those are 3D. They look 2D, but it's 3D. Yeah, see, look, you can see. And it works all around. See, look, you can even preview it here. So this is called an NPR, non-photorealistic render, which you can do as well. Any more questions, people? Nada. So what is your assignment? You do have an assignment. The assignment is render Apple, make Apple look real. More real Apple look, higher grade. Go. Rico.